premise or claim that we want to make about a population based on a sample of that population. Hypothesis testing allows us to draw inferences on a population by using sample data to make predictions. There are two hypotheses, the null hypothesis, represented by H0, and the alternative hypothesis, represented by H1. A treatment is administered to a random sample collected. If the sample mean is greatly different from the population mean, then it can be concluded that the treatment had an effect in the sample and may have an effect in the population. You'd say accept H1 and reject H0. However, if the sample mean is not very different from the population mean, then it is concluded that the treatment had no effect on the sample, so it may not have an effect on the population. The conclusion is fail to reject H0 and accept H1.
A population of college students is being studied. Their scores after a treatment are being predicted. So a sample of 72 students, n equals 72, is picked. The population has an average score of 142 and a standard deviation of 42. The sample mean is 137. What is the hypothesis conclusion for alpha equals 0.01? Well, so this should be simple enough to solve. Z would equal m minus mu over the standard deviation divided by the square root of the sample size, which is n. So z would equal 137 minus 142 over 42 divided by square root of the sample size, which is 72. From here, we can just use our calculator, and the square root of 72 is 8.49. So 137 minus 142 and 42 over 8.49. So we can divide this fraction. 137 minus 142, and then just use the calculator here. $4.95. And then minus 137. Negative 5. Negative 5 over 4.95. Divide that. Negative 1.01. Let's look for a z-score, like that. All right, here's the z-score. And it looks like the proportion in the tail is 1.562. And this is the proportion in the tail. For an alpha score of 0.01, the critical region is at c equals 2.53, and here z equals 2.53. Here it would be negative, and the HO region is here, the H1 region is here, the H1 region is here. So for this to be concluded as accepting H1, the z-score would have to been negative 2.53 at least, and it's only negative 1.01. So obviously, it's in the HO region because it's not in the H1 region. So we would accept the HO hypothesis. I'm gonna ace this final. I better. It's worth 100% of our grade. Are you all set with your final? Oh, all right, let's take a look. No. I'll see you next semester, or next summer. Maybe. Man.
In most statistical problems, the alpha level will be predetermined. So in our case, our alpha was at 0.01. For this situation, we're using a two-tailed test, so we would divide that by 2 so we get the proportion in each tail, which is going to be 0.005. When you use this and look at this proportion in the third column of the Z table, it shows you that the Z-score is going to be at 2.57 and negative 2.57 for this test. As stated in the previous section, this region is where we're going to accept the null hypothesis. This region out here is where we would accept the alternative hypothesis, making this region the critical region. In the two-tailed tests like we're using, if our alpha is set at 0.05, 5% of scores could be in the critical region. If our alpha is set at 0.01, only 1% of scores is available for the critical region. So it makes more sense when you want to avoid a type 1 error to use a smaller alpha, because that gives a smaller probability of your score being in the critical region.
There are a few rules when it comes down to accepting, rejecting, or failing to reject both the null hypothesis and the alternative hypothesis. You can accept the alternative hypothesis if there is a change in the population, or reject it if there is no change from the null hypothesis. However, for the null hypothesis, there's a little twist that comes with it.
The null hypothesis can never be accepted, only fail to be rejected. Data not sufficient to show convincingly that a difference between means is not zero do not prove that the difference is zero. In a similar sense, just because there is no evidence doesn't mean that a possibility doesn't exist at all. There's a chance that the null hypothesis can exist. Because we don't have data on the whole population, we must make do with sample data. From that data, we make inferences about the population. Even a random sample may not have all the characteristics of an actual population. So, just because the sample may indicate that a treatment has no effect does not mean that this assumption can be applied to the entire population.
If a study wrongly accepts H1, it is labeled as type 1 error. Suppose the same treatment was tested on a different group of 72 students. This time, however, they raised the alpha level to 0.05. Their sample mean was also significantly higher, coming in at m equals 155. With this information, we would be able to accept H1, even though we know that the treatment doesn't have any effect. Type 1 error is shown in the average person's life by things such as false positives on pregnancy tests or throwing good food out because it says it's past its expiration date.
Hello, my name is Fernando Lopez and I put the video together.
My name is Brianna Pierce, and I did the part about alpha in the critical region.
My name is Susan Donnie, and I did the test kit as well as explained why you can't accept the null hypothesis and definitions for the hypotheses.